Find the value of x between pi and 3 pi over 2. Right there, we should know which quadrant we're dealing with. Which quadrant are we in? Pi and 3 pi over 2. Pi, 3 pi over 2. That's quadrant 3. That solves this equation, secant x equals negative 2. Alright? Secant x equals negative 2. Secant goes with which? Cosine. So the cosine of x is what? Negative 1/2. Reciprocals have the same sign. Don't fall into that opposite reciprocal trap of the slopes in geometry class. Okay? Reciprocals always have the same signs. Okie dokie. You probably, is cosine an x value or a y value or a slope? At this point we should know it's an x value. The x value is negative 1/2. See if you can answer my question. See if you can answer my question. The x value that I've marked is a negative 1/2. See if you can answer my question. A lot of blankness. Which way from that red hash mark should I be going? Up or down? Oh, down, right? Because we said third quadrant. Yes. If only we could find out what angle measurement that was. Negative what? Okay, now I do realize that the y value at that spot is negative radical 3 over 2, but that's not what we asked for. We asked for the angle measurement. I need the angle measurement. You are correct about the y value. I will give you that. I need an angle measurement. I need a microphone that I can just hook on here so I can roam around the room and still be, getting picked up by that. If anybody knows of a good wireless mic or, that I can walk around the room and connect up to this computer, that'd be awesome. My phone? So can I do that? Yeah, I know, but connecting it up would be nice. Something that would just go straight to here. I'll ask you later. What do we got? Oh, speaketh the radian. Don't talk to me in degrees. I understand 240 is the correct degree measure, but don't you dare talk to me that way. Okay? Give me radians. Or give me death. Wasn't that what was it like? Patrick Henry, wasn't that what it was? Give me radians or give me death? Doggone, I need to write that down. That would be a good t-shirt right there. Sorry. Okay. All right, let's do this. Would you like me to count around the circle in pi over 6 increments? All right. So we got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. 8 pi over 6 would be reduced on the street to what? 4 pi over 3, thank you very much. Several of you said that before I gave you that answer, so that's the answer to my question. X equals 4 pi over 3. Now, is there another place on this circle that has the exact same x value? Is there another place on this circle that has the exact same x value? If so, what is it? 2 pi over 3, thank you very much, right? Now, why didn't I answer both of those? Because they specifically said you're only allowed to give me an angle between there and there in quadrant 3. That's why. That's the correct answer to this question. But you're right, 2 pi over 3, dot, 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 up here would have the exact same x value, right? So, you have to pay attention to what they give you in terms of where you are allowed to give your answer from. Okay? Solving a trigonometric equation graphically. Ooh, okay, we need our graphing calculators for this. Okay, so in y1 of our calculator, we can put x squared, right? Right, y1 equals x squared. That would be this side of the equation, right? What are we going to do for y sub 2? What other... Is there another person printing, or are we done? Is everybody back in the room? Because I do not want to die today. Okay? And we have been left exposed. Danger. Will Robinson and everybody else. Okay. Whew. Thank you for taking care of us and protecting us. What goes on what goes in question or equation 2? No, good try. I like what you're thinking though. You know there's no cosecant button on the calculator, so we got to think differently about this. All right? No, it's not second cosine because that would be sine inverse. Totally different. Ah, there we go. 1 over the sine of x. I know that you said sine of 1 over x. That was not true, but this is. So I'm typing 1 divided by sine x. 1 divided by sine x. Now you can see what they made their window if you want right down there. But, so that's what I would do. Go to my window. Now if you have negative 2 pi and 2 pi on your x's, that's still good, right? Because that's negative 6.28 and positive 6.28. That's pretty close to negative 6.5 and positive 6.5. But if you really want to make it look like theirs, you got the window right there. What? Oh, mode has to be in radians. Whoops. No. Don't go Takashi 69 on me. That was stupid. Okay, seriously. It's ridiculous. Okay, if you want to find the intersection, what you gonna do? Trace. So cute. So cute. What about what's over the trace button? The calculate feature. What are we going to calculate? Intersection. Yes, yes. That's the grown-up feature, right? This whole trace where you try to guess this, that's not cool. It's asking me if the first curve is y equals x squared. Well, sure it is, so I'm going to hit the enter button. Yes. It's asking me if the second one is y equals 1 over sine x. Sure it is. Hit the enter button. Okay, why isn't it? I hit the enter button. What's going on? It is. It feels like it's tweaking. Let's try that again. Calculate, intersect, first curve, yes, second curve, yes. What? Oh, okay. I had to get the cursor on screen. It didn't like that. It didn't like the fact that the cursor wasn't on screen, so I used my right arrow. It kind of brought the cursor into view, close to the intersection point, and now it's not panicking. Okay, now I can hit the enter button, and voila, there's your intersection feature. What is the x value that makes that true? 1.068. Yeah, that's good enough. Okay, so we had our two equations. Please make sure you don't do something like sine of 1 over x, that you actually do 1 over sine x if you're doing cosecant. If you're doing secant, it would be 1 over cosine x. What if it was cotangent x? 1 over tangent x, right? Okay, that's the kind of the idea. Hopefully you wrote that down in your example 4. Okay, so we have several problems for you to work on, but you'll be working on those probably next week. I would like to practice some graphing with you, and oh look, I made copies for you of this page so you wouldn't be leaving my room and trying to kill me like some right by the hand sanitizer. It's amazing how they make Kleenex come in rolls these days. Okay, so fireproof form. Help me get this in fireproof form. Y equals 2 sine 3x. Divide by 2. Excellent choice. Whoa, x over 1/3. Now, if you didn't see that magic happen, you could do like what we talked about before, where you take the 3x over 1 and you multiply by 1/3 to the top and the bottom, which is exactly the same thing he just quoted me. Okay, because those cancel, and we just get x over 1/3 while he checks his phone. Now, okay, I'm telling you, what do they teach you in advisory? Don't they give you the skills necessary to avoid the attraction of the attention? On. Seriously. It's like I'm blind and deaf. That's what you guys think. Whew. All right. Oh, it's recorded. Okay. Now, I think it would be funnier if next year I do the recording with my face in it over the top and go, what the heck was going on in my class? All right, now, period. What's the period of the function? It's not 2 pi, folks. 2 pi over 3, that's true. If you take 1/3 and you multiply it by 2 pi, you do get 2 pi over 3. A third of 2? 2/3. Sorry, math humor. Okay. How about that amplitude? 2, right? We did a vertical stretch by 2. So horizontal shrink by 1/3, vertical stretch by 2. So if I ever ask you again for the description, how is it related to the original sine function, hopefully you'll say those kind of things. Like horizontal shrink by 1/3, vertical stretch by 2. Okay, now, graph it. What's your HK? We need our HK. Right? 0, 0 is your HK. Okay, go for it. Graph your sine wave. Okay? Graph the sine wave. You know it. Repeats every 2 pi over 3 units. How far to the right should I go before I find the point where it starts the cycle over again? 2 pi over 3. So that should be, you should have an entire cycle in between those 2 dots. And yes, this is a sine function, not a cosine function. Okay, now, do me a favor once you kind of get the approval like these guys here. Go ahead and do probably 4 cycles of that. Okay, once you get 1 cycle done and you're confident with that, then stretch it out nice. And go 4 cycles. Probably 1 to the right and 2 to the left. Okay, now. Okay. Same thing I experience with fractions. People hate fractions, and they're not afraid to say it. I mean, there's probably a lot of hate crimes out there on fractions. Everybody to that point? Okay. Now, for those of you who care enough to listen to me and watch the video from last night, I'm not talking to you other people, just talking to the people who care. All right? I know, salt in the wound. Just make sure you go back and watch that if you haven't, because it's necessary to help you understand this whole process. When you flip this thing over, right? Yes. Because it's 4.7 part 1. Yeah, it's a short one. Okay. And so if we're trying to graph the one at the bottom, 2 cosecant 3x, it's related to this one. So if you understand how to do 2 sine 3x, like we just did, then we can easily find the cosecant version of this. Now, I really need you to understand how to be able to do this so that you can do the next part. A reciprocal means you're flipping the fraction over, correct? What happens when you take an x-intercept, a 0 of the function, and you flip it over? What do you get? It becomes an undefined value, right? And yes, as you know from last night, that becomes an asymptote of the function. Every time we have that's a lot of asymptotes, right? Yes. Okay. Don't touch them either. Okay. Shame on you. Touch the asymptotes. Okay. Yeah, don't make that mistake again. The math preacher has spoken. Okay, so every single x-intercept is going to create one of these asymptotes, right? And so can you remind me from what you learned last night what's going to happen in between every one of those asymptotes? Come on, what's going to happen? Here, let's zoom in on what happens between those hills. Right between yes. I will describe it to you as a fake parabola. Now, why in the world am I describing it as a fake parabola? Yes, it will touch the tops of every one of those hills, which is why it's really important for you to know the amplitude of the function so that you can get that point in the right spot. Yeah, they keep going out forever and ever and ever, and they never have what? Parabolas never have. I mean, we got lots of red dashes for these. They never have asymptotes. That's why I call these green things fake parabolas. Because, yeah, they kind of remind me of that parabolic shape, but that's not what they are. Likewise, you're going to see the same types of things happen over here. Now, so what does the cosecant graph look like? Kind of like this. That's the cosecant graph we're looking at. But it's really kind of hard to do that unless you know what the original sine function looks like. That's why I'm completely okay with you doing like a dashed line for your sine wave, and then do the solid lines for these little fake parabola things. does it take to complete one cycle of this particular function? What's the period of this function? Okay, now, at first glance, people are going to say 1 pi over 3. But, remember, a complete cycle has to complete the pattern over again. So this pattern and this pattern are not the same. So what's the period? How long does it take before it duplicates itself? 2 pi over 3. In other words, the period of that original sine function is exactly the same one for the cosecant function. Right? Can you describe to me the domain of that function? The domain of this function is not all real numbers, but you are not too far off. What's the domain of this particular function? All reals except... good call. Except integer multiples of pi over 3. Every time you hit another pi over 3. Now the notation I'm going to try to push you towards, which you are going to see more in the future, and you need to be able to understand it, and don't just say to me, well, is it okay if I just write except integer multiples of pi over 3? Sure. Now you can use the word except, but I want something like k pi over 3 where k is an element of the integers. Okay? That is what we're going to see and what we're going to write. And I need you to understand it, be able to read it, be able to write it. I have seen people use the letter n before. N pi over 3. It doesn't matter what letter you choose. As long as you're telling me that k is an integer. Okay? Next. Fireproof form. Y over 3 equals cosine of what? X over 2, right? X over 2. Alright, so what's the period? The period has been stretched by 2, so it's now 4 pi. Okay? And the amplitude? 3. Okay, graph the cosine wave. Try to speed this up so that we can get to the next one as well. HK is sitting at 0, 0. Is that point on my curve or under a max? Under the max. So we came up 3 points. We go over to the right 4 pi. Halfway in between, we're at the bottom. All this cool stuff. And duplicated on the left. Duplicated on the left. Should have that. We should have 2 cycles. That's all we could fit on this particular graph. Now we need to do the secant. Okay? What's going to happen at pi and at 3 pi and at negative pi and at negative 3 pi? What's going to happen at those spots? Pi, 3 pi, negative 3 pi. Come on, tell me what magic thing's going to happen at these spots? Vertical asymptotes. Okay. So I'm expecting that you would be graphing something like these. And because this particular graph stops here, you'll have these portions that you see right there. And of course, that is the finished product of my secant graph. What's the domain? What's the domain? All reals except k pi, where and we probably have to specify where k is an odd element of the integers. Now there is a fancier mathematical way to do that, but I really don't want to scare you with 2k plus 1. I figured that would freak you out. So, I know. So, okay. Tonight when you're catching your Z's. Okay. Any questions about this? Graph the original, then find the asymptotes, and then graph the other parts to it. Tangent. Now, we haven't done a lot with tangent because that was introduced in this section. I kind of introduced it a little bit early. And what do we have here in terms of fireproof form? Y equals tan of x over 2, right? Okay, so we know there's no amplitude to a tangent function, but what's the period of this? Now remember, the tangent was the one that had a period, an original period of pi. And so now we're stretching it by 2, and so we have a period of 2 pi. We know that 0, 0 sits on a tangent wave, and the distance on either side of that has to be a total of 2 pi. So if it's got to be a total of 2 pi, where should I be putting those vertical asymptotes, at least for the first one? We want to go to 1 pi and negative 1 pi, because the distance between them would be 2 pi. Okay? So this is our tangent, right? Draw me two more cycles, and maybe some half cycles. How far over would I go for my next, to the right, how far over would I go for my next asymptote? 3 pi. Okay, so we could do this again. Kind of looks like those jet streamers. Okay. A couple half cycles at the end because we ran out of room. Okay. How do I use this to graph a cotangent wave? Okay, so what happens at these x-intercepts that I'm circling in red? Those are the new asymptotes. I know this is going to be messy, folks. We've got our new asymptotes for the cotangent function. Those green vertical asymptotes are no longer vertical asymptotes. What are they? When you take an undefined value and you flip it over, what do you get? Good try. My guess was horizontal line. That's not true. So an undefined value, 1 over 0, right? That's what an undefined value is. Flip it over. You get 0. You mean it's an x-intercept of the cotangent function? Yes, it is. I've often wondered if it should, if I should be considered a math preacher or a math sorcerer, with my book of spells over here. It could go either way. Okay? Now, those vertical asymptotes now turn into the x-intercepts. And what happens when you take those waves or those cycles and you invert them? They flip. That's okay, we'll get rid of the green. Whoa. Did I miss something here? No. I did, didn't I? Daggone it. What did I do wrong? I was using the wrong, because I'm colorblind, I was using the wrong, using the wrong vertical asymptotes. Okay? What do you mean, don't copy me? Oh, you were laughing at me? Okay. Alright, folks. Now I'll get rid of the green ones so that we're not dying. Now, what's the domain before we leave? What's the domain? All reals except... Okay, now you see that even multiples, like you've got even multiples of what? Or we could say k times 2